So we've been talking a lot about exponents, except for now we're going to be talking about whenever the exponent is up here for the number that we're raising the power to. Alright, so just evaluating the exponential function, it says the function f(x) is equal to 2 times 3 raised to the power of x. This is the model that an insect population after x amount of days. What will the population be on the 5th day? So I know that x is my days, and I've been given the number 5, so all I'm going to do is plug that into the problem. So I'll get fx is equal to 2 times 3 raised to the 5th. If I just plug that into my calculator, I will get 486 insects. Alright, so now whenever we're going on to the next section about identifying exponentials with a table, what we do is we take the difference on the x's and then we divide on the y's, and if the change is consistent, then that means it is an exponential function. If the change is not consistent, that means it is not an exponential function. Alright, so here we go. -1, the difference between a 1 and a -1 is 2. The difference between a 3 and a 1 is positive 2. The difference between 5 and 3 is positive 2. Now on the y's we are dividing, so a -9 divided by a positive 9 is x -1. This one, 9 and 27, is x3, because 27 divided by 9, and then 45 divided by 27, x 1 and 2/3. Okay, so since these are not consistent, that means it is not exponential. Okay, then over here, 0, -1, plus 1, 0 and 1, plus 1, 1 and 2, plus 1. Okay, so that one's good so far. Okay, now the difference, or the division between 3 divided by 1.5, x2, 6 and 3, x2, 12 and 6, x2. So yes, this one is exponential. So side note, the change in y must be a constant ratio. So the x's, it's just the differences, but for the y's, it's set up as a ratio. Okay, so now whenever we're graphing these kinds of functions, it's going to look like this. Okay, so this says for y equals abx, if b is greater than 1, then the graph will go this way. So like the arrows will be facing to the right, and they'll go up and then go down. However, if b is less than 0 or less than 1, essentially, between 0 and 1, it will be facing to the left. Okay? So, a side note on this part is if A is positive, they will turn up. Turns up. If A is negative, turns down. Okay? So this is where A is negative, right here, negative, positive. Okay? So now this one, our example, is we're going to graph 5 times 2 raised to the x. Okay? So we want to know the A positive. She made a note of that, so we're going to graph those. And so she wanted us to use the points -3, -2, -1, 0, 1. Okay? And if we just plug those into our calculator, we will be able to see that -3 is equal to 0.625. Negative 2 is equal to 0.125. Negative 1 is equal to 2.505, and then 110. And you're just going to go over here to your graph and plug those points in. Okay, there we go. So that's whenever A is positive. Alrighty. So our A in this problem is the 5. So we can tell that it's a positive and we're going to be turning it up. Does that make sense? Alright, so that's it for these little notes. I'm going to do a few examples on the math homework next.